Okay, let's continue chapter 8, lecture 8.8. In this section, we're trying to stop the simulation even after 4:30. So we'll stop the incoming arrival, not allow any customer enter in the system, but the system continue running until all the customer got served with arrived before 4:30. And so here we're trying to do is, and also we're trying to determine how long the simulation run after the hours, or we call it overtime. So the first objective that we're trying to do is we shut down the arrival source using a stopping condition. And we can either stop the source using maximum number of arrival, or we can also use maximum time for the arrival. The third way of stopping the source is using an event. A certain event happen, we can terminate the source to generate future arrival. We'll talk about the last one a little bit later in the later example. And also, once the system still continue running after the source is shut down, and when the simulation itself will be terminated. So we need to have an add-on process to use to add an add-on process to end the run of the step. So at 4 p.m., in case there's no one left in the system and the current simulation time is after 4 p.m., then we should stop the simulation. We're using an add-on process right here to do that. We show you either in the number of entity in the system is less than 1 and the current simulation time is greater than 7.5 hours. Again, we want to collect statistic. We call it using an output statistic to collect the statistic. When is the time after this after hours the simulation has run. So here we're trying to do is we give you in the slide, we give you all the detail for running, how we set it up, but now I'm going to switch to the model, actually demonstrate how we're going to do this. This is what the model we have left from section 8.7, and we still have this appointment arrival called schedule arrival source arrival, and the so walk-in arrival. The schedule arrival, I'm not too worried because you only have a arrival in our cases, but this walk-in arrival continues generate, so we're going to using a stopping condition. Here what we're trying to use is after 7.5 hours, I'm going to stop the simulation, stop the source to generate any future arrival. That takes care of the first things. The second thing is after certain condition, I want to shut down the simulation. So I'm using an add-on process, a generic add-on process. I'm going to call this add-on process time to stop. Okay. We're trying to decide a specific condition. This condition is either the current simulation time is greater than or equals to 7.5 hours. So I have a run time now is greater than or equals to 7.5 hours already. And the situation is the population of these applicants, we call the entity applicant, is population. Number in the system is less than or equals to 1. Okay. Then these are the conditions. If this condition is successful, we're going to end the simulation, called end run. So basically terminate the simulation back then. Okay, when we're going to run this time to stop, actually, in our model, all the sources when the entity got, when we try to destroy all the entity, we need to run this check. So this destroy entity portion, we're going to run that time to stop the simulation. All right, let's see if this is working okay. Let's try it. And one more thing. The thing is, we trying to run the simulation between 8:30 to 4 o'clock. And now, since we want the system continue to run even after 4 o'clock, and then we should say the ending condition is unspecified. Let it run until we shut it down using the add-on process. Okay, we see if we can run this. Actually, this is running for if you look at the here, is total simulation time underneath in the bottom, say 11.84 hours. So we want quite a bit of time actually for that. Here we, instead of just looking at the bottom of the screen every time we run the simulation, we want to collect that information for the future uses as a statistic. To do this, we're adding a so-called output statistic as a collector for when the simulation stop after the regular hours. We call them time after closing. Okay, it is an output statistic. Is a time unit is time actually. What is the expression to use? It's basically the simulation time, run time out, time now, minus the 7.5. Okay, and the unit is hours. So then I will try to report using this output statistic to determine when this simulation stop after the 4 o'clock. All right, let's run the simulation again. We make sure when the simulation stops, there's no applicants in the system. The system is empty. We go back to see the result. We have walk-in, okay, to see, and time to closing actually is 4.3 hours after that. So we can see how these are running. Go back, and now we're trying to see is when we have using this statistic in average basis. So we create a new experiment. I'm going to add 3 different response. Okay, and the first response we call it collecting flow time for the walk-in. And I'm going to start collecting tally statistic. We defined it a little bit ago. The walk-in flow time, and it's average from each one of the replication. So average flow time for each of the replication, and the time unit is time, and I want to use minute for that. And the second response is actually flow time for the scheduled appointment. All right, the expression is using the tally. I define it for the scheduled customer. This tally statistic, we define it for scheduled. And of course, I want to collect the average of each one of the replications. So we're running 10 or 100, and time units time, reporting minutes, how many minutes the schedule. And the third one we're trying to do is the overtime. We'll call it overtime, which means time after the 4 o'clock. So what we do is basically using the output statistic for time to closing, time after closing output statistic, and its value. I'm trying to report as unit is time, but this time I want to use hours instead of minute. Okay, and I want to run this instead of a 10 replication, running 100 replication, and start letting it run. All right, after it's finished running, and I can go to my response result. We can see this is the so-called chart for either walk-in or schedule or overtime. So overtime is around, on the average, is about 2.7 hours overtime, and then maximum could be close to 6. Minimum is like over the 100 iteration replication. That's about 0.4 hours. We can show the histogram, we can show the observation, and the limit and all that. Okay, so we can see each one of the category we define in the response. Also, we can see that over this pivot grid, and giving you the time after closing is 2.7 on the average. Walk-in customer is about 2.2 hours, 2.25 hours, and scheduled hours is 0.59 hours on the flow time. So this pretty much concludes this section. We talk about using how to stop the input, okay, arrival source, and how to terminate a simulation at the sink using an add-on process called time to stop. We check if the current simulation time is after hours. Also, number of the customer within the system is less than 1. We end the simulation. Again, we're using an output statistic to collect how much overtime we are running for each one of the run. And again, we have the tally statistic for the walk-in and the scheduled assignment. So this will conclude the entire chapter A, and also conclude this section 8.8. All right.